And for the record, those spacecraft didn't last long. This is because temperatures on Venus are hot enough to melt lead at around 880 degrees Fahrenheit. Hot enough the ground would glow a dull red. The atmospheric pressure at the surface is 92 times the sea level pressure on Earth, or the same as being 3,000 feet underwater. It would crush you, and any spacecraft not built to withstand the immense pressure. The thick clouds are mainly carbon dioxide, but also have a layer of reflective sulfuric acid with the smell of rotten eggs. It's not a place you would want to be, or could survive more than a few seconds. Venus is too close to the Sun to sustain life as we know it, and averages a distance of about 67 million miles away from the Sun. However, about 3 billion years ago, the Sun was only 80% as luminous as it is now. With that in mind, it's possible that this hellish planet could have had an environment much like the Earth. And for about 2 to 3 billion years after the planet formed, life could have had plenty of time to emerge. The Pioneer Venus spacecraft launched by NASA in 1978 and several other space explorations have helped us study the planet and reveal some details on how it transformed from an Earth-like planet to the hellish place it is today. Evidence was found showing there may have been shallow oceans on the surface of Venus for 2 to 3 billion years, and temperatures on the planet would have ranged from a low of 68 degrees Fahrenheit to a high of 122 degrees Fahrenheit. It would have been easy for life to flourish under these conditions, and where there is water, there is a good chance of life. Ancient Venus was certainly a lot different than it is now, and it's been theorized that it formed out of ingredients similar to Earth, but followed a different evolutionary path. Its rotation rate around the Sun is 117 days compared to Earth's 1 day. But scientists say it's possible Venus once had the same rotational period as Earth. It had more dry land than the Earth, especially in the tropics, and the surface was ideal for making the planet habitable with plenty of water to support an abundance of life, and there was plenty of land to reduce the planet's sensitivity from incoming sunlight. But around 700 million years ago, some kind of massive resurfacing event triggered a runaway greenhouse effect, causing the planet's atmosphere to become very dense and very hot. No one knows for sure what caused this massive catastrophe to happen, but some researchers believe that volcanic activity may have been the cause, as magma and molten rock bubbled to the planet's surface, releasing huge amounts of carbon dioxide trapped in the planet's crust when it rapidly cooled after forming 4.2 billion years ago. This sounds like a scary occurrence, and similar events have happened here on Earth. The Siberian Traps is a huge 3 million square mile region of volcanic rock in Siberia, Russia. It's the evidence of a massive eruptive event that happened in the last 500 million years. The 2 million year eruption released toxic amounts of greenhouse gases and caused a mass extinction. So now that we know quite a bit about Venus, could simple life forms be struggling to survive on the planet after millions of years? And how would we know? Recently, scientists say they've discovered a chemical called phosphine in the clouds of Venus. Phosphine is made up of 1 atom of phosphorus and 3 atoms of hydrogen. It's also been detected here on Earth, on Jupiter and Saturn. So, how is this discovery of phosphine evidence for life? The one thing that got researchers excited about the smelly flammable gas is that, as far as we know, phosphine can only be made by life, whether it be humans or microbes. Humans have made it to use as a poisonous chemical weapon that was used in World War I, and it's still made as an agricultural fumigant. But the interesting thing is that phosphine is also made naturally by some species of anaerobic bacteria. These are organisms that survive in oxygen-starved environments, such as landfills and marshlands. With that in mind, researchers set out looking for phosphine on other planets, since finding it could indicate the presence of alien metabolisms, and they found it in the clouds of Venus. Using the largest astronomical telescope in the world, the James Clerk Maxwell Telescope and the Atacama Large Millimeter Array Telescope, researchers measured trace gases in the Venus atmosphere. Phosphine should not be in the Venusian atmosphere at all. It's extremely hard to produce, and the chemicals in the clouds should destroy the molecules before it can accumulate in amounts large enough to be observed. So, what could be creating the phosphine? Some scientists say it's too early to conclude life does exist on Venus, and that the data needs to be verified. And the phosphine fingerprint could be a false signal introduced by the telescopes or data processing. But if phosphine is really floating through the clouds on Venus, it suggests one of two things. Alien life forms are linking together phosphorus and hydrogen atoms, or there is some completely new chemistry that we don't know about that's creating phosphine in the absence of life. Despite the sulfuric acid in the clouds of Venus, they also carry the basic ingredients for life as we know it: sunlight, water, and organic molecules. And scientists have speculated for nearly 60 years that life could possibly exist on the planet. Near the middle of the cloud layer, temperatures and pressures are nearly Earth-like, and there are molecules in the planet's air that alien microbes could metabolize. The possibility of finding bacterial life in the clouds of Venus is important, because the earliest evidence of life on Earth comes from fossilized mats of cyanobacteria called stromatolites in Greenland, which are around 3.7 billion years old. But the fact that life could live in such extreme environments is something we already know about. Around 4 billion years ago, there lived a microbe called the last universal common ancestor, or LUCA. There is evidence that this microbe lived an alien lifestyle because it was hidden deep in underground iron sulfur-rich hydrothermal vents. Being both anaerobic and autotrophic, it didn't breathe air and made its own food from the dark, metal-rich environment it thrived in. This microbe's metabolism depended on hydrogen, carbon dioxide, and nitrogen, which it turned into organic compounds such as ammonia. The most remarkable thing of all was this tiny life form was the beginning of a long lineage that covers all life on Earth. Now that the biosignature of phosphine gas has been discovered in the clouds of Venus, there are missions being planned by several institutions, including California's Rocket Lab, who plan to send a spacecraft to Venus in 2023 to hunt for definitive signs of life. The mission will use two pieces of Rocket Lab hardware: the 57-foot-tall Electron booster, which is currently used to launch small satellites into space, and the Photon satellite bus, which recently made its debut flight. The Photon will launch atop the Electron booster, then it will make its way to Venus on a flyby trajectory. When the Photon gets close enough, it'll deploy a probe into the atmosphere. Its goal will be to hunt for signs of life in the deck of Venus air that is habitable. But before the mission, everyone will get a chance to see the Electron and Photon in action, as it's booked to take a NASA satellite to the Moon in early 2021. And speaking of NASA going to Venus, they have 4 finalists for the next round of Discovery missions. 2 of these newly announced finalists are targeting Venus. One of these is the Da Vinci Plus mission, which would send a probe down through the thick Venusian atmosphere while gathering data on the way. The second is the Veritas mission, which is set to map Venus's surface in detail from orbit. This probe's observations would help show the planet's geological history and could confirm if volcanism and plate tectonics are active on the planet today. Many planetary researchers say that Venus is truly undervalued, and that we need more missions to study the planet to get a more detailed understanding of its history and its evolution. This could help us understand what happened to the planet, and if our planet is next and will end up like Venus. Since the beginning of the space age, mankind has developed many new technologies to help better study the universe, our galaxy, the solar system, and look for evidence of extraterrestrial life. Look at this tiny pinhole of light in space. That's us. That's planet Earth. On August the 25th, 2012, 35 years after it was launched, Voyager 1 left our solar system. On its way out, it snapped a photo of the Earth from 3.7 billion miles away before turning off its cameras to conserve power. Now it's reached interstellar space, and after 43 years and 4 months, the spacecraft still communicates using the Deep Space Network. But Voyager 1 found that interstellar space is a lot weirder than we thought. What have we discovered, and why is it so important? In the summer of 1964, NASA developed ways to study the outer planets of the solar system in the NASA Jet Propulsion Laboratory. Engineer Gary Flandreau predicted that by the end of the 1970s, there'd be a rare alignment of the planets Jupiter, Saturn, Uranus, and Neptune that only occurs once every 175 years. This alignment of the planets would allow mankind to visit all 4 planets during a single mission. The flight would change its trajectory at each planet and increase the speed of the probe enough to reach the next point in its flight path. Gravity maneuvering, or slingshotting, is when a spacecraft is pulled by a planet's gravity and increasing speed as it shoots around the planet, saving tons of energy and time. As an example, flight to the farthest planet, Neptune, could only take 12 years instead of 30. The Mariner Jupiter-Saturn project began in early 1972 at a cost of $360 million. In March 1977, just a few months before launch, due to the mission's importance, the probes were renamed Voyager 1 and Voyager 2. The Voyagers were equipped with computers that could be reprogrammed, allowing researchers to change programs and fix any problems on the fly. On August the 20th, 1977, Voyager 2 was the first sent into space, 16 days before Voyager 1 would be launched. But because it was on a trajectory that took longer to reach Jupiter and Saturn, Voyager 1 would eventually pass it. Since 1962, there's been interplanetary missions to study Venus, Mars, and Mercury, with missions lasting up to 3 years. But the probes would need to last long enough to be part of the Grand Tour project at NASA, which needed 2 probes to study the 4 gas giants, Jupiter, Saturn, Uranus, and Neptune. But it was later suggested that Voyager 1 and 2 visit only 2 planets. Information in the press spread saying that only Jupiter and Saturn would be visited, reducing the overall cost of the project. Experts looked at over 10,000 trajectories before they chose 2 that would allow them to fly by Jupiter's largest moon, Io, and then Saturn and its largest moon, Titan. This route also gave the spacecraft the opportunity to continue towards Uranus and Neptune. The thought of extraterrestrial civilizations intercepting these probes was on the minds of researchers. American astronomer Carl Sagan, along with his team, created a golden record. With 115 images encoded in analog form, spoken human greetings in 55 languages, a variety of natural earth sounds like wind and thunder, sounds of animals like birds and whales, and different music from around the world.
Hello from the children of planet Earth.
Which probe made the first planetary mission? The original mission plan was for the Voyagers to operate and last only 5 years. It would be long enough for them to study Jupiter, Saturn and its rings, and the 2 planets' largest moons. However, as the mission continued, the ambitions of scientists grew, and the Voyagers outperformed well beyond what was expected. On March the 5th, 1979, Voyager 1 was 173,983 miles away as it approached Jupiter and was able to snap images of its moons Io and Europa. And although Jupiter has been one of the most studied planets in our solar system, new photographs gave researchers unseen angles and more information about these planets as if they were new worlds. The new images of Jupiter's closest moon, Io, had yellow, orange, and brown surface colors, showing scientists evidence of volcanic rock. At least 8 active volcanoes were spotted on Io, shooting material into space, and stunning images of this were captured when Voyager flew by. Io turned out to be the most volcanically active body in the solar system. A little over a year after launch, Voyager 1 approached Saturn on November the 12th, 1980. Expectations were greatly met, and researchers were able to expand their understanding and knowledge of Saturn. 3 new moons were discovered: Prometheus, Pandora, and Atlas. But the biggest accomplishment was getting new information about Saturn's largest moon, Titan. It's the only moon in the solar system that has a thick atmosphere. Similarly, it was discovered that the upper layers of Saturn's atmosphere consists of 7% helium, and the rest is hydrogen. Voyager 1 also discovered Saturn's G-rings, disc-shaped plains made of ice and dust. Another interesting discovery was Saturn's 6th largest moon, Enceladus, which was found to reflect more solar light than any other object in the solar system because of the fresh, clean ice covering its surface. Images were captured that showed its crater-ridden landscape, indicating some geological activity under the surface that could be a source of heat for a liquid ocean. But Voyager 2 was about to make some discoveries of its own. On July the 9th, 1979, Voyager 2 made its closest approach to Jupiter and snapped this amazing photo of Jupiter and its moon Io, casting a shadow on the gas giant. On August the 25th, 1981, after successfully arriving at Saturn, the probe snapped images of the gas giant's rings and moons. It was clear at this point that Voyager 2 could now fly to Uranus with all its instruments remaining functional. NASA asked for more money and instructed the NASA Jet Propulsion Laboratory to extend the Voyager 2 mission to Uranus and Neptune. On January the 24th, 1986, the Voyager 2 probe approached Uranus at a distance of 50,600 miles above the icy cold cloud tops and gathered data that revealed 2 new rings, 11 new moons, and recorded the surface temperature of Uranus at a chilly -353 degrees Fahrenheit. Uranus rotates at an angle, and its magnetic field is displaced from the axis and plane that all other planets are found in. The data also showed that both of Uranus's poles have the same temperature, although only one receives sunlight. Researchers figured the planet must spread temperature in different ways. Recently, researchers were going over the decades-old data and studying the 45-hour convergence of the probe and Uranus when they noticed a 60-second jolt in its magnetic recording. It was discovered that Voyager 2 flew through a plasmoid, a giant magnetic bubble, that might have been carrying the atmosphere of Uranus out to space. Actually, all planets leak atmosphere into space, and even Earth's atmosphere does the same thing. But don't worry, we have enough atmosphere to last billions of years. When Voyager 2 approached Neptune, researchers didn't think they'd see anything other than darkness. NASA crews increased the size of Deep Space Station's radio antenna in Canberra, Australia, to catch the incredibly weak radio signals that the probe was relaying from Neptune. On August 25, 1989, Voyager 2 was 30,000 miles away from the 8th planet in the solar system. Approximately 30 times farther from the Sun than the Earth, Neptune receives only 0.01% more sunlight than the Earth. In almost complete darkness, Voyager 2 started taking mysterious photographs. They revealed the makeup of the blue planet, showing the presence of methane, 6 new moons, and 4 rings. Like Saturn and Uranus, the rings and Neptune's 4 moons made a complex, interconnected system. The probe also discovered winds measuring 1,500 miles per hour around a strange, previously unseen place on Neptune named the Great Dark Spot, a massive, rotating storm the size of the planet Earth. In fact, both planets, Uranus and Neptune, are known for strong winds that can reach supersonic speeds 10 to 15 times stronger than on Earth. Uranus and Neptune were originally thought to be gas giants, but in the 90s it was discovered that they were made up of heavier substances, and they became a distinct class of planets called ice giants. Triton was no less impressive. This moon of Neptune is located to the planet's north. It's the coldest of all natural bodies astronomers have discovered at a frosty -391 degrees Fahrenheit. Voyager 2 was able to approach the planet at a distance of about 25,000 miles and discovered active geysers that spewed nitrogen into space. Triton was the final object that the space probe would meet in the solar system before heading out into the great unknown. Where will the Voyagers go next? The Voyager's interplanetary missions have been completed, providing astronomers with lots of new knowledge and a better understanding of our solar system. These 2 probes, together, made huge breakthroughs in astronomy. Distant object in space made by humans, and Voyager 2 was the first to study the 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, and also entered interstellar space in November 2018. But when Voyager 1 went into interstellar space, the instrument that measures the temperature of plasma had stopped working, but Voyager 2 still had a working instrument. Our Sun does a lot more than just provide light and warmth. The entire solar system is moving through space and is surrounded by a bubble called the heliosphere. This bubble is continually inflated by plasma coming from the Sun and is known as the solar wind. It extends 11 billion miles from the Sun's leading edge, surrounding all 8 planets and beyond. And a good thing too. Outside the heliosphere, in interstellar space, radiation levels and cosmic rays are a lot higher than inside the bubble. The Sun's solar winds are protecting the entire solar system as it flies through space. The heliosphere extends far beyond the region of Pluto until it encounters what is called the termination shock, where its motion slows abruptly because of the outside pressure of the interstellar medium. Voyager 2 discovered that the interstellar medium was at least 54,000 degrees Fahrenheit, but the plasma is so thin and diffuse that the temperatures around Voyager 2 remained extremely cold. The Voyagers have started supplementary missions to study the outer regions of the solar system in interstellar space. These two probes are still speeding across interstellar space and will never return to the solar system and only have the infinite reaches of space ahead of them. NASA's website shows where the voyages are in real time. They're getting further and further away from the Earth, every day letting us know we could expect the unexpected. It seems there's no other place in the universe with a dense atmosphere. Mountains, sand dunes, plains, lakes, rivers and oceans, except the planet Earth. But it turns out there's actually a place much like the Earth in our solar system that has a complex weather cycle, landscapes carved by liquid, and volcanic activity. It may even resemble the Earth in its earliest stages, and some scientists think it might be better to colonize it first instead of Mars. This is Saturn's moon, Titan. Recently, something bizarre was found hidden in its orange clouds. And because of this, NASA is now planning a mission to Titan. But what did they find? And why was it so important? Before we get to that, let's learn a little about this strange world that orbits Saturn. Our solar system is home to more than 150 moons, but only 4 of those have an atmosphere. One of those is Titan, the second largest moon in our solar system, and the largest moon of the planet Saturn. Titan is also the only place in the solar system other than the planet Earth that has liquids on its surface. It has a weather cycle much like ours, but has clouds that rain frozen liquid methane and ethane instead of water. Titan could be the best place for human colonization. In fact, the conditions are right for a self-sustaining, long-term human settlement. Titan is a remarkably Earth-like world that has a thick atmosphere, about 4 times as thick as Earth's. The atmospheric pressure is about 60% greater than on Earth. Imagine swimming 50 feet underwater to give you an idea. This means you wouldn't have to wear a bulky pressurization suit if you were walking around on the surface. The atmosphere would also keep out deadly radiation, energetic particles from the sun, and galactic cosmic rays from making it to the surface of Titan, making it a safe environment for humans. Mars doesn't have such protection. People living on Titan could walk or bounce around since gravity is only 14% of the Earth's. If you strapped some wings on yourself, you could literally fly around under your own power. But it's very cold on Titan, because on average it's 886 million miles from the sun. You would need a suit to keep warm, because the surface temperature is about minus 290 degrees Fahrenheit, and the only sunlight that reaches its surface is like late sunsets on Earth. Of course, you'd also need to wear a respirator to breathe. Titan is tidally locked to Saturn, meaning one side always faces the planet. It's 759,000 miles away from Saturn, and has a radius of about 1,600 miles. It takes the Titan 15 days and 22 hours to make a full orbit of Saturn, and 29 Earth years to make a complete orbit around the Sun. No one is certain what Titan looks like under the surface, but on January 14th, 2005, the European Space Agency's robotic lander Huygens made a dramatic descent through the moon's orange, smoggy atmosphere and landed on the surface of the moon. The camera on Huygens shows a desolate-looking surface and captured the trademark yellow haze, which revealed intricate details of the atmosphere's layers, winds, and mysterious chemical processes. Based on data from the Cassini-Huygens mission, Titan has 5 primary layers of rock. The soggy moon has a core of water-bearing silicate rock surrounded by a shell of special water ice called Ice 6 that's found only at extremely high pressures. This high-pressure ice is surrounded by a layer of salty liquid, and an outer crust of water ice sits on top of this. The surface is coated with organic molecules that have rained or settled out of the atmosphere in forms of sands and liquids. The presence of lakes and seas on Titan brings up an interesting question. Could there possibly be any forms of life there? In 2005, scientists at the Southwestern Research Institute in Texas and Washington State University said that several of the crucial elements for life on Earth are also on Titan, even though the conditions are far harsher than Earth. Some life forms are a lot tougher and stranger than we think. Take, for instance, Deinococcus radiodurans bacteria, an extremophile that was in outer space for 3 years outside of the International Space Station, enduring microgravity, harsh ultraviolet radiation, temperatures near absolute zero, and still managed to survive. If there's life on Titan, it could be hidden underground, and a lot weirder than we think. The Cassini spacecraft revealed that the moon is hiding an underground ocean of liquid water mixed with salts and ammonia. Titan could potentially have environments with conditions suitable for life as we know it in the subsurface ocean, or bizarre alien life that we don't know about yet in the hydrocarbon liquid on the surface. But what happened there recently that drew our attention there? In 2016, a team of scientists identified a molecule called cyclopropenylidene, C3H2, in Titan's atmosphere that's never been detected anywhere else except deep space. The discovery was made using the Atacama Large Millimeter Array, ALMA, that's made up of 66 radio antennas. These all work together, creating a single giant telescope. ALMA uses a technique known as interferometry, where all antennas are pointed in the same point in the sky. The antennas pick up a signal from the target in the universe and join forces to analyze the signal. By combining radio waves from the antennas using a supercomputer, researchers can obtain extremely high precision images. In order for ALMA to get these images, there must be a perfect synchronization between all 66 antennas and the electronics with the precision of a millionth of a second. Using this incredible technology, researchers found something they didn't expect to find: a weird molecule called cyclopropenylidene. C3H2 is a strange organic molecule that doesn't exist terrestrially on Earth and can only be seen in a laboratory. C3H2 was first discovered in clouds of gas and dust throughout the Milky Way, including the Taurus molecular cloud. This simple carbon-based molecule may be a precursor to more complex compounds, and it could form or even feed possible life on Titan, like organic molecules that formed life on Earth between 3.5 and 3.9 billion years ago. C3H2 is the only other cyclic or closed-loop molecule besides benzene to have been found in Titan's atmosphere so far. Closed-loop molecules like it are important because they form the backbone rings for the nuclear bases of DNA and RNA, which is also a critical compound for life's functions. However, C3H2 is not known to be used in any modern-day biological reactions. NASA says the molecule could be an indicator for life, since something has to be generating an unstable molecule. If there is life on Titan, it would be incredibly different from water-based life forms we know of. NASA was so intrigued by this new discovery on Titan that it wants to study the moon more and announced the Dragonfly mission in 2019, which is planned to launch in 2027. It'll take 9 years for it to reach Titan, arriving in 2036, and will cost a total of $1 billion, including its ride into space. The Dragonfly is a very unique spacecraft design, and is much like a large quadcopter drone, with 2 rotors on each of the spacecraft's 4 corners, hence the name Dragonfly. When it arrives at Titan in the year 2035, it'll need to travel to different areas for study. The Mars Curiosity rover used special tracks to roam the red planet. But with Dragonfly, scientists decided to take advantage of the moon's low gravity with a flying vehicle. This will be the first time that NASA will fly a multi-rotor spacecraft for science, and Dragonfly will be able to make vertical takeoffs and landings. Despite the lower gravity on Titan, it still needs electricity to fly around. So the Dragonfly is equipped with a radioisotope thermoelectric generator, a type of nuclear battery that converts heat from decaying plutonium-238 into electricity. This means it could fly and operate on Titan for decades. Since Dragonfly can easily fly around, it can be moved so that it's always facing the Earth for direct communication, which takes 70 to 90 minutes each way, since Titan is so far away from the Earth. During its proposed 2.7-year mission, Dragonfly will take advantage of the dense atmosphere that'll keep cosmic rays and radiation from destroying it. And it will fly to many different locations to pick up surface materials for chemistry experiments. It'll also check out the planet to see if it's possible for humans to inhabit it one day. Since the building blocks of life, or the organic molecules on Titan, are expected to be similar to those on Earth before life arose, Dragonfly will help study how far pre-life chemistry has progressed to see how life evolved on our own planet. See, we have no idea how life really formed and began on our planet. All we know is that it involved organic molecules. Dragonfly will check out the moon's atmosphere, what the surface is made of, and the ocean that lays below the surface, looking for complex organic materials that are the keys to life. Now, the only thing left is to build the spacecraft and get it ready to launch. Even if we don't find what we're expecting there, the Dragonfly mission will show us a lot more about Titan. It seems that we may soon find life on another planet or moon, and that'll be a very exciting time for science and humanity. Everyone knows that Jupiter is the largest planet in our solar system. It's 318 times as massive as Earth, and 2.5 times bigger than all the other planets combined. It's a gas giant, and for a long time, scientists haven't exactly known what lies beyond the violent swirling clouds in the atmosphere. But now, scientists have discovered what the inside of Jupiter really looks like. What have they found? And has Jupiter really saved the Earth from total annihilation because of its incredible size? Our solar system began as a disk of dust and gas some 4.6 billion years ago. The first planets to form were the gas giants Neptune, Uranus, Saturn, and Jupiter. Jupiter took shape about the same time as the rest of the solar system, forming around 4.5 billion years ago. Its strong gravity pulling in massive amounts of gas and dust from the disk before all the other planets formed. It was the first and the largest. Jupiter is mostly made up of hydrogen and helium, about 90% hydrogen and about 10% helium, almost the same composition as our Sun, which is about 70% hydrogen and 28% helium. Some astronomers call Jupiter a failed star. However, the gas giant only has a mass of 1/1000th that of the Sun. Jupiter just isn't massive enough for gravity to trigger nuclear fusion. The beautiful whirling clouds and storms that you see in images, the layer resting on the surface known as the troposphere, are about 31 miles thick and are made up of ammonia, ammonium hydrosulfide, and water, which form the distinctive red and white bands. When you look at Jupiter, you probably think that it must have a solid surface. The fact is that Jupiter doesn't have a true surface. It's mostly swirling gases and liquids, and if you sent a spacecraft there, it would have nowhere to land. But just because the spacecraft wouldn't have a place to land doesn't mean it would fly right through Jupiter's atmosphere and come out unharmed through the other side. This is because extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize any spacecraft trying to fly into the planet. But we've sent spacecraft to orbit and explore the planet. The $1 billion Juno probe, the farthest space probe ever to be powered by solar arrays, was launched towards Jupiter on August 5, 2011, and arrived in orbit around the planet on July 4, 2016. And what we've discovered and learned about Jupiter is incredible. The newest discovery using data collected from the Juno spacecraft found that the colorful stripes of swirling gas and dust you see in Jupiter's atmosphere were found to run 1,800 miles deep and hold so much gas that the mass is about 3 times that of the entire Earth. These belts of wind flow at speeds of 223 miles per hour and disrupt how mass is spread across the planet. It was also discovered that Jupiter's atmosphere is rotating differently, with zones and bands rotating at speeds that are different by up to 328 feet per second. Those bands on different colors you see are actually traveling in opposite directions. Lighter bands move in the direction of Jupiter's rotation, circling the planet faster than it spins, and the dark-colored bands move slower in the opposite direction and take longer to move around the planet. So how does a giant ball of gas floating around in space stay together and form a planet? The Jovian magnetosphere is the cavity created in the solar wind by Jupiter's powerful magnetic field, ballooning 600,000 to 2 million miles and tapers into a tadpole-shaped tail extending more than 600 miles behind Jupiter. This magnetosphere is the largest and most powerful of any planetary magnetosphere in the solar system. Jupiter's magnetic field is generated by electrical currents in the planet's outer core, which is composed of liquid metallic hydrogen. This magnetic field was found to be almost 20,000 times as powerful as Earth, and rotates, with the planet sweeping up particles that have an electric charge. The electromagnetic storms they generate are so strong that they can be heard by amateur radio operators on Earth beamed towards us by plasmas and magnetic field lines. These signals are sometimes even more powerful than radio signals from the Sun. This magnetic field traps swarms of charged particles and accelerates them to very high energies, and creates intense radiation that bombards the innermost of its 67 confirmed and named moons, and would destroy anything that got close. Speaking of Jupiter's moons, scientists have recently discovered an FM signal emanating from one of Jupiter's moons, Ganymede. If you want to see a video about this mysterious signal and Jupiter's giant moons, let us know in the comments. By now you may be wondering, does Jupiter have a solid inner core? Studies have found the planet's interior moves as a single body and behaves as if it were a rigid solid, despite its fluid nature. For now, we simply do not know if Jupiter has a solid core or not, but the Juno spacecraft should be able to help discover this, and what the mass and makeup of this solid core is, if it exists. We do know that at Jupiter's core, whatever it's made of, the pressure is about 100,000 times the pressure on Earth. The Great Red Spot is one of the most iconic features of the planet. It's a massive storm the size of the Earth that's been raging since it was first sighted in 1831. Trapped between two jet streams, it's called an anticyclone that swirls about a center of high atmosphere pressure and rotates in the opposite direction that hurricanes do on Earth. It's the largest storm in the solar system, with wind measured around 400 miles per hour. Compare that to the fastest wind speed ever recorded on Earth of 231 miles per hour. One day this great red spot could end up disappearing completely, and scientists say that it's been shrinking since the 1800s, and may only last another 20 years. NASA's Juno spacecraft was able to snap incredible images of the planet as it passed at 5,600 miles above the giant red spot clouds in July 2017. One of the amazing things that was discovered is that deep in the atmosphere, pressure and temperature increase greatly and compress the hydrogen gas into a liquid. This gives Jupiter the largest ocean in the solar system, which is made of hydrogen instead of water. Juno also grabbed some spectacular images of the gas giant's poles, discovering another incredible wonder of the planet. At the North Pole of Jupiter, a huge persistent cyclone is visible, and encircled by smaller cyclones ranging in size from 2,500 to 2,900 miles. On Jupiter's South Pole, the same thing was discovered as Juno did a flyby, and using infrared cameras imaged a cyclone the size of the entire USA, with 5 other cyclones swirling around it in a geometric pattern, which also rotate counterclockwise. The NASA Galileo spacecraft was likely the first to discover these hotspots when it accidentally flew through one on its way to a planned demise to the surface of Jupiter. When the spacecraft was almost out of fuel, NASA deliberately sent the craft on a no-return plunge into Jupiter on September 21, 2003. This was done to protect the moon Europa, which some say has a subsurface ocean that could contain life. It's worth mentioning that we probably should be thankful for the planet Jupiter's size and the powerful magnetic field that it generates, because it's possible that Jupiter has saved the planet Earth from certain doom. People were laughing at the prospect of an asteroid or comet hitting the Earth in the late 80s and early 1990s. But then something happened that would quiet that laughter. The comet Shoemaker-Levy 9 was discovered by Carolyn and Gene Shoemaker and David Levy on March 18, 1993, using the Schmidt telescope at Mount Palomar. Scientists calculated the comet was originally 1 to 1.2 miles wide, However, tidal forces from Jupiter's powerful gravity had broken the comet into more than 20 pieces as it made its close approach to the planet sometime in 1992. But the biggest revelation was scientists saw that the fragments were going to smash into Jupiter, and luckily for NASA, its Galileo orbiter was still on its way to the gas giant. Many Earth-based telescopes and orbiting spacecraft such as the Hubble telescope all were focused on the incredible event that was about to happen. The fragments of the comet were lined up like a freight train and collided with Jupiter's atmosphere, unleashing the force of 300 million atomic bombs. The fragments created huge dark spots in the clouds that measured 1,200 to 1,900 miles and heated the gas giant's atmosphere to temperatures as hot as 53,000 to 71,000 degrees Fahrenheit. If a comet of this magnitude hit the planet Earth, the results would be devastating, with impacts sending dust and debris into the sky, which would cool the atmosphere and absorb sunlight, and envelop the entire planet in darkness. This historic Jupiter comet impact is what led to planetary defense. But fear not, this type of collision was very rare, and scientists say probably only occur every few centuries. Or do they? On August the 7th, an amateur astronomer was looking at Jupiter through his telescope when he captured an asteroid colliding with the atmosphere of Jupiter, creating a white flash visible in the clouds. Some scientists say these impacts are inevitable, with the amount of objects floating around in space and Jupiter's massive gravity tugging on anything that gets close to it. We could say that Jupiter's like Earth's big brother, and likely protecting us from asteroid impacts. We've learned some new things about Jupiter and how its layers of atmosphere are made up. And we've also been able to image the planet in striking detail, piecing together images captured at the perfect moment for clarity called lucky imaging. The highest resolution image of Jupiter ever seen has been created in thermal infrared light. In the photos you can see the familiar banding. Bright regions are clear air, where heat from inside the planet can leak out, and darker regions are where the thick clouds block the heat from escaping. This proves that the interior of Jupiter is very hot, heat left over from its formation billions of years ago. When taking a look at Jupiter through the Hubble telescope, what you see is sunlight reflecting off the cloud tops. With these amazing images, we're learning more and more about Jupiter every day. And we're not done yet. Juno is still on its mission, and only about 1/3 through its planned mapping of the planet. And there are still reasons to believe that Jupiter may have a rocky center that's enveloped in a layer of metallic hydrogen. We're definitely going to get more incredible images of Jupiter coming soon. And we're about to unlock the mysteries of the biggest planet in the solar system. So make sure to stay tuned here to see the latest stunning images of Jupiter. Before modern telescopes, humans could only imagine what the surface of the Sun and the planets looked like. Now, advanced technology has made it possible to get in close and take images of the Sun and the planets deep in our solar system. Now, get ready to see the solar system as you've never seen it before, and see images that were so good they shocked astronomers. Burning with the energy of 1 trillion nuclear bombs per second, the Sun is the largest body in our solar system, accounting for 99.86% of the total mass. One of the most dramatic images of the Sun was captured by the Solar Dynamics Observatory on August 31st, 2012. when a long filament of solar material that had been hovering in the Sun's atmosphere erupted into outer space. This beautiful but deadly coronal mass ejection, CME, traveled at over 900 miles per second. The planet closest to the Sun, orbiting at an average distance of 36 million miles, Mercury, has been studied by many spacecraft throughout the years. But NASA's Messenger spacecraft was the first to orbit the planet. Images showed the surface covered in craters in all sizes and massive asteroid impact sites, like the Van Eyck crater, which is 168 miles in diameter, and the Calorus Basin, which is 960 miles in diameter, with mountains at the outer rim 1.2 miles high. These are images with spectral surface measurements that were taken on April the 29th, 2015. Messenger snapped more than 200,000 images of Mercury before ending its mission in 2015 with an intentional crash into the planet's surface. The probe's demise was inevitable, as Messenger had been orbiting Mercury since March 2011 and had run out of fuel. Right before impact, it sent back its final image, the highest resolution photo of Mercury ever captured. You'd think that Mercury would be the hottest planet because it's the closest to the Sun, but our next planet is actually the hottest in the solar system. The second planet from the Sun, and also Earth's closest neighboring planet, Venus, has a thick atmosphere made up mostly of carbon dioxide, sulfur dioxide, and nitrogen gas, which traps the heat of the Sun, making it a hellish world. Venera 13 was a probe built in the Soviet Union for the Venera program to explore Venus. It was the first lander to transmit color images from the surface of Venus. Venus is a hot world, with surface temperatures as high as 880 degrees Fahrenheit. The probe was designed to only last 30 minutes, but it must have been built like a tank, because it continued to transmit data and images for more than 2 hours after landing on March 1st, 1982. NASA then sent the Magellan spacecraft to Venus in 1990 to image and map the entire surface. It sent back images of the planet's surface showing evidence of volcanism, tectonic plate movement, turbulent surface winds, and miles of lava channels, including one measuring 5,550 miles long. Another incredible image of the volcano Mat Mons that rises 3 miles. Once Magellan was finished mapping the entire surface, it also ended its mission and crashed into the fiery planet. The third rock from the Sun, the Earth, is very unique, and the only place known to have life in the solar system. There have been lots of amazing images taken of the planet we live on, but modern satellite photos are probably the most breathtaking, like this image from NASA of the Earth as it looks right now. This amazing true color image was taken by NASA's Moderate Resolution Imaging Spectroradiometer from 22,000 miles above the Earth, and shows North and South America as they appear from orbit. The Moon also making a guest appearance in the background. And on December the 14th, 2020, NASA captured a total solar eclipse with the GOES 16. That's quite amazing. But here is something you may not have seen. In March 2011, a Russian satellite named Electro-L captured incredibly detailed images of the Earth that appear to rival NASA images. Many claimed that they are more accurate and show different things, but NASA say they're not accurate. We're not sure. But which images do you think are the best? And by the way, remember the Messenger spacecraft? It snapped a photo of the Earth and of the Moon and sent us a postcard before speeding towards Mercury. Mars has always been of great interest to humans. The fourth planet from the Sun, the red Martian planet, has been studied heavily. The Viking Orbiter 1 took stunning snapshots of Mars in 1979, like this photo of the Valles Marineris. And the Viking 2 orbiter snapped an image showing the southern polar plains and polar ice cap. In 2013, the Mars European Space Agency's Mars Express took highly detailed images of Hebes Chasma, the northernmost part of Valles Marineris, as seen in this movie created from the images. But since then, 4 rovers have already been on the planet's surface, studying and snapping photos. The images from the Mars Curiosity rover, including a selfie, were the most incredible images from the surface of an alien world. This is a 1.8 billion panoramic view made up of over 1,200 images of Mars as seen by Curiosity, which is still operational. The largest planet in our solar system, the gas giant Jupiter, has the most unique look of all the planets, with its giant Great Red Spot, a storm on the planet that's been raging for 350 years, and is so large it could swallow the Earth whole. On July 10, 2017, the Juno spacecraft flew just 5,600 miles above the Great Red Spot and nabbed the closest image of the massive storm ever taken. This image, a bit farther away, is a little bit truer in color to what we would see if we were orbiting Jupiter. But Juno also captured unbelievable images of polar regions, which cannot be seen from Earth. And what surprised astronomers was that Jupiter's North Pole has 8 storms swirling at its center, and they're laid out in a precise geometric pattern, the storms appearing as stable fixtures in Jupiter's atmosphere and not normal weather. But more incredible photos would come, and on November the 13th, 2018, a new image from Juno was created using data from the JunoCam imager that's nothing short of breathtaking. And on June 27th, 2019, the Hubble telescope captured the planet's trademark Great Red Spot, which researchers say is shrinking. We got an awesome video coming up on Jupiter, so make sure not to miss it. As the #1 contender for the most beautiful celestial body in the solar system, Saturn is hard to beat with its iconic rings. And probably the best images of Saturn to date come from the Cassini-Huygens spacecraft. On October 21st, 2002, the spacecraft was 177 million miles away from Saturn when it snapped this photo. And on March the 27th, 2004, as it got closer, took this natural color image as it neared its arrival into Saturn's orbit. Now here's a mind-blowing image of Saturn you may never have seen before. This is Saturn backlit by the sun, and with that added light, Cassini was able to image the ring system in a way not possible from Earth, and the result is stunning. But in 2004, the Hubble telescope was also in on the action and snapped an amazing photo of an aura. In 2016, the Cassini spacecraft sent back images of Saturn's northern hemisphere. What scientists were surprised to see was a hexagonal vortex storms. They've been studied, but no one's sure how this forms. On September the 15th, 2017, the spacecraft made its final approach towards the gas giant, and before sending this final image, burned up in Saturn's atmosphere like a meteor. Known as the sideways planet because it rotates on its side, the 7th planet from the Sun. One of the best images taken, Voyager 2, made a flyby of the planet in 1999, and this image was taken using 3 color filters. And on July the 11th and 12th, 2004, A composite image of Uranus obtained by the Keck telescope was published showing the icy cold world and its rings. Those bright spots that you see on the surface of the planet are auroras. In November of 2011, the Hubble telescope snapped an awesome image of Uranus, and a colorized photo shows an icy blue sphere with red rings. And in 2017, the Hubble telescope captured auroras again on Uranus. Neptune is the 8th planet in our solar system and the farthest away from the Sun. The only spacecraft that's been close to Neptune is Voyager 2. One image taken by the spacecraft shows a giant storm raging on the surface of the planet, Neptune's great dark spot. Before Voyager 2 would complete its mission and head towards interstellar space, it made a close approach and snapped this image showing bright cloud streaks in Neptune's atmosphere. The Hubble telescope has taken a recent image of Neptune and in December 2020 snapped this image with the Great Dark Spot. Because it's so far away from us, the best images we have of Neptune from Earth so far was taken by the European Southern Observatory's Very Large Telescope using a special narrow-field adaptive optics mode of the multi-unit spectroscopic explorer instrument. Many argue whether Pluto is a planet or not, but you're here to see some photos. One of the clearest images of Pluto that you'll ever see was taken by the Long Range Reconnaissance Imager, which is aboard NASA's New Horizons spacecraft on July the 13th, 2015. But it wasn't done yet, and on the next day, this image was put together by combining blue, red, and infrared images taken by the spacecraft. The New Horizons spacecraft continued to take crystal clear images of the planet. Pluto also has a moon called Charon, as seen in this composite of enhanced color images. And this image is the most striking, showing mountains across an icy plain. Humanity has achieved great results getting new images from planets in our solar system and making incredible discoveries. We're still too far away to get close images of Proxima Centauri, the next planetary system to ours, and current spacecraft headed in that direction will take thousands of years to get there. But there are plans to create a wafer-thin nanoprobe called Breakthrough Starshot that has thin sails to capture energy from a powerful Earth-based laser. This would accelerate the probe at 134 million miles per hour, meaning the tiny probes could reach Proxima Centauri in 20 to 25 years. Just think of the images it could take. If that happens sometime soon, you'll see it here.